Hello everyone, I'm Xiaogang. This chapter is mainly about speech recognition. What is speech recognition? Actually, we call it STT or ASR, both of which refer to speech recognition. So STT stands for speech. S means speech to text. And this ASR stands for automatic speech. Automatic speech recognition, R-code something like that. So this chapter mainly covers this content. Before we talk about this content, let me draw a diagram for you to explain these concepts and what they mean respectively. As the name suggests, it converts a piece of audio into text. So we call it speech recognition. And this technology in digital voice and sequence processing has been widely and practically applied. Such an application. Then in this chapter, we mainly talk about IFLAC's real-time speech recognition interface notes. We are talking about IFLAC's real-time speech recognition interface, because speech recognition is divided into many types, and it is divided into types such as, for example, this real-time type. It's like you're speaking at the same time, and then this translation, it pushes it to you as you go. Then there's also the file-based type. File-based, based on a piece of audio. This type is based on a piece of audio. So with this type, you upload a file or upload a piece of audio. Then it returns all the results, parts back to you. Or it doesn't parse part of it and sends it back to you. So it's divided into many types. Right, now let's talk about the most difficult one. It's the real-time kind. Because uploading files like this or uploading a piece of audio are all very easy to solve. So why is this kind the most difficult? First, you have multi-threading, and this multi-threading is not just a simple 1 or 2 threads. It's very likely 3 to 4 threads, right? 3 to 4 threads to do such a task. It is very complex, and at the same time, it also involves our network legend, network transmission, also set to this audio format, right? And then what? Things like Grazel are all child's play in it, Jishin coding. These are all basic knowledge. The troublesome part is that it requires multi-threading. It has 3 to 4 threads and then network transmission using big endian and little endian, agreed upon format, because you're definitely not writing in the same language. Then you have different manufacturers, and it also needs to have involving the audio format, audio objects, how to capture audio streams in such situations. After these things are processed, only then can you continue further to further complete such a task. Then, so these gradually present some difficulties. And in this concept of writing code, you cannot just lump it all together, because once you lump it all together, you won't be able to break it apart. You must write it in a modular way. That is, separate each function. Write it as a modular concept. Why should this code be modularized? Actually, it definitely belongs to a modular thing. Why modularize the code? It's because you might need to be cross-platform. You might have the PC version and the Android version, right? There is the Android version. There is the iOS version. If your code is not cross-platform, then congratulations, you will have to write the same code 5 to 6 times. Writing it 5 times is very normal. Of course, is it possible that you only write one copy of the code, then make all platforms support it? Of course it is possible. So this tests everyone's architectural skills. Then it's very simple. Because we rely on excellent cross-platform capabilities. So as long as we meet the conditions for excellent cross-platform support, we can implement these features. Okay, good. So this is a basic concept. Next, let's extend this to real-time voice. How should it be architected? Let's open a new diagram here. Let's switch the screen. Switch it. Okay. So obviously, let's first talk about the normal architecture. In a normal architecture, it might be the client. Let's take this client we're about to write as an example. So you might be using UE5, right? UNU, or you might be using Unity. Then UE5 may target multiple platforms, such as PC, Android, right? Else, we won't go into those. Unity is the same, also covering 5 platforms, right? Okay, as for the server side, there's only one server side. For example, we are currently using this for training and flying. iFlyT, right? This is the server side. Then, we only need to ensure communication between the client and the server, because we are doing real-time speech recognition now. So for communication here, it continuously sends this kind of audio byte stream, segment by segment. That is the audio byte stream. Then this segment continuously received, right? It contains our recognized text information, which is then sent back. So now our interaction is this kind of process. This kind of process interaction is completely fine. Then let's continue looking below. But there is this method can be used across platforms. Very easy to use. Actually, there are also some other methods. It's possible that they might not want to set up the server because the cost of the server is very high because it communicates through this which, well, right, you have to establish a connection every time. And also this bandwidth is actually the same as ours. The bandwidth understood is the same. That is how much, because when you transmit audio, you can calculate the audio byte stream bandwidth. So this puts a lot of pressure on the server. Then there is actually another way. Another way is an integrated approach. Integrated means everything is on the client side. Everything is between the client and the server. It is integrated. And here, in the form of a DLL, you access it. Then you only need to capture the audio stream on the client side. And then through this code-based approach, interacting in this way through code, then that is also acceptable. This method is also acceptable. As for this method, it won't be very cross-platform because, Android and iOS, the third-party libraries they use have different formats. So this kind of library becomes quite troublesome. You need experienced and skilled personnel to develop this kind of library. Only then can it be called. So actually, if you don't want to write this library, you can set up a server locally and have it locally communicate with the server. That works too. For example, when we do this kind of similar to what NVIDIA provides, that audio wireless unliminals, that Ocado platform, lip syncing and such. Actually, this is pulling up server locally. This approach actually does not require you to deploy the server in the cloud. It also runs locally, but it does so through this interaction with the EXE via network communication. Then let's briefly explain that we need to use this one here, or the next one. We need to use the switch point, right? Okay, we go through. In the previous chapters, we taught you about HTTP, right? HTTP. Okay, so here we have our HTTP server, right? Then, for example, our HTTP, it actually works like this. Send an HTTP request, and then this side returns a response. We should write down several pieces of this information. Everyone must follow along and practice, because this is very important. So here we have RSP, right? Spinzo, okay. Then, for example, HTTP, it has some status codes, right? For example, the most common one is this code, which is our SSR, right? 7D4, and then we also have some body, right? The most commonly used body, and some header, right? So actually, the above is equivalent to our HTTP, which can only interact one time after another, right? Back and forth. So this creates a problem. That is, if you want to do stuff, right, when maintaining some long connections, then you won't be able to do this. Because every time you send HTTP, you create this object, then the server responds and then processes it. This is good. If we have some frequently used in, then you might need to create multiple times, create connections, then break connections. This puts a lot of pressure on our server. Actually, sometimes we need, and also your HTTP server, you cannot actively interact with this HTTP to communicate. You should understand what I mean. You cannot actively request data from HTTP, even if you can only have the client send messages to the server. Then the server returns data to the client. Of course, you are very smart. Are you saying it's very simple? I'll just set up an HTTP server on the client side too. Right, but in reality, that makes things very complicated. Because the HTTP server you set up on the client side, it actually doesn't have a public domain name or port. It's troublesome to set up anyway. But if you're on the internal network, you say there are two HTTP servers communicating with each other. Can they communicate with each other? Right? Well, Of course, that is possible. There is no problem at all. It's just that they act as clients to each other and servers to each other. So if you communicate like that, then they can definitely communicate with each other. You can send me a message. I can also send you a message. But writing it this way is complicated because actually we already have our own. We have something relatively mature. So that's where WebSocket comes in. So we can send messages to each other, right? So this WeChat is how should it be used? The way it is used is actually very simple. For example, we are the client here. We're the client, client, and we are the server here. So here we have iFlyText server, and then here we are equivalent to it's sending a WebSocket, WebSpec. And then, actually, on this side, it is the server provided by Weibo. Yes. Then, after they establish the connection, the first step is to establish this connection. Usually, the client requests the server to establish the connection. After the connection is established, they enter the communication phase. Then, after entering the communication phase, the client can continuously send information to the server. For example, A1, A2, A3, A4. In fact, the server can also continuously send information to the client. B1, B2, B3. Okay, once they stop communicating, we can do it from either end. We can close it from either side. So this is actually a WebSocket. This is one way of communication. But there are actually many details, like what its underlying structure is, how it establishes connections, what methods it has. We won't go into those here. If you're interested, you can search online some of the things their computer science department does, some introductions to network communication. For example, what is TCP? What is UDP? Right. And then what is HTTP? And then what is WebSocket? And then some more complex communication methods, like GPC and all sorts of other stuff. You can go and take a look at them. And then, for example, during an interview, they will ask you what is the three-way handshake? What is the four-way wave? We won't go into these things here because this is basic computer science knowledge. We actually have these concepts in UE5, but when we use them, we are actually working at a high level. So there is no need to study these low-level details. That is not necessary for now. Okay, so this is our communication approach because in this chapter, we will cover client-to-server communication. Then in the next chapter, since you will write a one-shade server from scratch and a well-keyed client and server, this can be used in our server because our servers need to communicate with each other. Because why? Because this instance A, instance B, then when you jump, it actually needs to switch servers. Then instance A and instance B must communicate. Right. And we also have an instance management server. We call it instance S. And it also needs to manage the states of instances A, B, C, D. So this part needs to communicate with all instance servers. At this point, using HTTP is not suitable. HTTP is more suitable for a gateway-like server or a login server because it is not suitable for acting as the central server. We call it the S server, called the central server. Then this central server, it communicates with many servers. If you use HTTP, it is not convenient. Then we use WebSocket, using client West HA and 0 in this way. Okay, that is the kind to be discussed later. Then we will explain to everyone here. Next, we will explain to everyone. That is to say, why is this real-time voice recognition? It is very complex. Then another reason why it is complex, it lies in this multi-layer point. Okay, so why is this multi-layer relatively complex? First of all, this box got dragged off. First of all, you have an audio track, right? So you have an audio track, right? Once you have an audio track, then you definitely have a separate audio thread. Okay, let's call it the A6 thread. Then it needs to capture the audio, right? Capture audio. Okay, so here, because it involves UA, you must embed it into UA's thread to achieve this cross-platform capability, modularity. So in the end, it has to be designed this way. Then if you have a captured audio, then you definitely need a thread that consumes audio. We can call it the consumer. And this thread that consumes audio, this thread is specifically used to consume audio. So obviously between these two threads, they need to operate on a piece of data. Okay, so this is the second thread. This is the consuming thread. First, in this process, you definitely need a main thread. You're designing a main thread. So why do you need this main thread? Because your game is done frame by frame. done by tick. So you say, then the life and death cycle of these two things is managed by it. So your main thread needs to manage the process of a due and customer. Then, since you have the third thread, then the fourth thread is our let thread. For this let thread, you can use TCP, UDP, HTTP. You can manage whatever you want, right? Then for this thread, you can't put it on the main thread to do something, because you know that when you send and receive data, it will block. So here we call it the network thread. This network thread is for processing data. So the main thread captures audio here, consumes audio. Then when consuming audio, it sends this audio. So it sends it through the network thread. Then here it is transmitted over the network. So it is transmitted as binary ball-over data to our server. Right, server. I misspelled this, just ignore it. Sometimes I don't remember it either. Regardless of how many R's there are specifically, then on the server side, after it comes back here, this is the binary data of the audio being sent. Binary audio data. Of course, some of it is binary, and some is unfortunately JSON. That doesn't matter. It depends on the interface requirements provided by your server vendor. Follow this progress. Then here, it will return this JSON. Okay, return this JSON. After this JSON is returned, it goes back to the network layer. Then the network layer, at this point, comes back again. He comes back again. He returns to the main level. Return to the main level. Then at this moment, the main level, through the blueprint manager, calls back to the blueprint, returns to our BT. Right. So actually, the entire interaction flow is like this. It is actually quite complex. Let's briefly count. In fact, this part involves E, D, T, quash, 4 threads. Right. Okay, so that concludes this lesson for everyone. Through the method of drawing, we explained real-time speech recognition, its entire interaction process and its complex points, then as well as the simple difference between 回直 and HTTP. Thank you everyone.